even we can move on to moving. If you and me hugged, well, that would be wonderful. We would both get so much out of it. But if during the hug you suddenly ran away from me while yelling, "I'm leaving you at a velocity of 2 meters per second," well, I would be devastated. But I would know that deep down you still cared for me because you told me your velocity. And if I know your velocity, I can know just how far away you are from me at all times. All I have to do is take your velocity and multiply it by the number of seconds that have elapsed since you left. Now take a look at what a graph of your velocity would look like. Here we have velocity in meters away from me per second, and we have time in seconds since the hug ended. Now, if your velocity is 2 meters per second and that persists, then here's a graph of your velocity. But look at this. After a number of seconds have elapsed, like after 1 second, the distance you are away is just the rate times the time elapsed, 2 times 1. Well, that also happens to be the area of the rectangle bounded by a line coming up from the time, your velocity graph, and our axes. Well, that's pretty convenient. After 2 seconds, you are 2 times 2, 4 meters away from me, which is also the area of this shape we've created. After 3 seconds, you are 3 times 2, 1, 2, 3, 4, 5, 6 meters away. It's always the area. Well, that's pretty convenient. But let's change up the story. What if we hugged and it was great? I mean, just almost not even a hug, like something new is being invented here. But then, during that, you suddenly leave. You run away from me. And while you run, you yell, "I am leaving you at an ever-changing velocity." Well, I would say, you know what? That is a lot less helpful. Now let's say that this changing velocity you have that I don't know happens to be an acceleration of 2 meters per second per second. What does that mean? Well, that means that your velocity is getting bigger by 2 meters per second for every second that you run. It would look like this on a graph. You begin hugging me with no velocity, and then 1 second later, your velocity is 2 meters per second larger. So 2 larger than 0 is 2. That's your velocity after 1 second. After 2 seconds, your velocity is 2 larger still, so 4, and then 6. Your velocity graph would look something like this. But now here's a question. If you're moving like this, is the distance you are away from me at any given time still just the area of the shape bounded? It's harder to see that because you don't maintain any single velocity for any amount of time. Your velocity is always changing, so we don't have nice rectangles. But we can see that it is true by putting ourselves in my shoes. Abandoned, alone. I don't even know your motion. I don't even know how you're accelerating. It's very scary. But I can decide to take matters into my own hands and measure your velocity as often as I like. Let's say that I measure it just once. I measure it after, let's say, 2 seconds. All right, wonderful. Now the question I want to answer is how far away you are after 3 seconds. All right, so I have this measurement. I know that you were traveling at 4 meters per second. Well, I mean, look, if you're going 4 meters per second for 1 second, then that's a rectangle like this. And it's got an area of 4. But you're not 4 meters away, are you? You're a lot further than that because you weren't traveling 4 meters per second for this entire second. You were at all times actually traveling a bit faster. And I'm totally forgetting all the distance you covered before my measurement, which is not 0. Okay, so clearly I need to measure your velocity more frequently. So let's say that I measure your velocity twice during the 3 seconds I'm curious about. Let's say I measure it after 1 second and then after 2 seconds. Well, now I can imagine rectangles here. This one is 2 by 1, so it has an area of 2. This one is 4 by 1, so it has an area of 4. 2 plus 4 is 6, but you're a lot more than 6 meters away as well, because you weren't traveling 2 meters per second this entire time. You were actually speeding up, covering more and more distance. I'm totally forgetting all the distance you covered over here. Basically, this method will always leave me short. But the more frequently I check your velocity, the better things get. Take a look at this. Oh yeah, Oh, wow. As you can see, the more frequently I check your velocity, the closer my calculation gets to being based off of what you really did, your actual motion. But also, the more frequently I check your velocity, the closer the combined area of all of my rectangles gets to simply being equal to the actual area bounded by your velocity curve. Which means that the area under your velocity curve, even when your curve is like this, is still totally the distance you are away from me. Now let's take this knowledge and apply it to the odd number rule. Before people knew how things fell, there were some pretty good guesses. For example, if the reason things fall is that they have within them a desire to be in their own proper place, in this example, the table, well then maybe the closer this object gets to the table, the more excited it is to be there and the faster it goes, in which case its velocity would change over time like this, getting steeper and steeper and steeper. But Galileo didn't think that.